Full disclaimer, this video is officially over, regardless if this board works or not. This is definitely a board that's not worth fixing. I'm going to show you how to fix this completely dead Sony mainboard. The customer sent it in, stating that their TV one day just stopped working. So our first step is plug it into our test jig and confirm the fault. Now typically after about 10 or 15 seconds, we are supposed to be getting our standby light, as well as I do have a flash drive with an LED light on it that is supposed to light up once the TV gets the 5 volts. And lastly, our optical light is also supposed to turn on. None of those 3 lights are currently turning on, thus confirming that this mainboard is not turning on and activating as it should, and is indeed the fault. Now there is something else going on with this mainboard that we haven't told you about yet, but first let's go ahead and take a look at it at our test bench. The most common cause of the dead no power symptom is the eMMC chip. The easiest way to diagnose it is to remove it and install it into our memory diagnostic tool.
And now to check the life on this eMMC. That's probably the cause of the dead Sony. Now we'll go ahead and remove this eMMC and put a good one in here, and we'll begin to program it.
Programming can take between 15 to 20 minutes, so in the meantime, let's finish prepping the board. We are now ready to install our newly programmed chip. Now typically after replacing the eMMC chip, we would be live testing the board in our test jig. However, we did not tell you earlier that the customer had claimed the HDMI ports stopped functioning before the TV went completely dead. Now that can commonly be caused by the HDMI processor right here, and often it will short out. So before we live test the board, let's make sure there are no shorts on the HDMI processor. For this board, I want to focus on the top right corner, and more specifically, this large capacitor right here. And I'm getting about 1.7 ohms. That's a short. Now on our good board over here, this board is showing 24.31 kilo ohms, and this is a known good working board. So we'll go ahead and replace the IC chip and then recheck the capacitor for shorts. I've been preheating the main board with our bottom heat at 300 degrees Fahrenheit. Now I'm going to add a little bit of flux. And with my heat gun, we're going to be doing about 375 Celsius at 100% air. Okay, we're having a little bit of a hard time. I'm going to bump it up to 400. Starting to get a little give. There we go. And while the board is hot, using my desolder wick, I'm going to remove the excess solder left behind. And now just a little cleaning. Now that the chip is removed, let's recheck our resistance. And I am getting OL, so open loop. For these large chips that have the large ground pads, we always want to put some solder paste first. And I think I've mastered the art of not putting too much. Yeah, that still looks like a lot. And this is what the solder paste looks like when we're zoomed in all the way. All right, let's go ahead and line up our chip best we can. So the way I'm going to do it is I'm going to put a big blob of solder on my tip, bring that down on the board in a way that I don't actually touch the actual chip or the pins or the board, but hopefully solder the actual chip down. So now, in theory, it should be locked in on those, I guess not 1, but 4 or so pins. And if I adjust the chip up here, yep, I'm getting some resistance now. So I can go ahead and lock in this top left pin. Actually, before we start soldering, I did notice we have a couple bent pins, like the one down here. So we'll want to go ahead and straighten those out first. And it usually is going to be those corner pins that get hit. Alright, and we do have a lot of excess, so let's go ahead and remove that with our desolder wick. So actually, we're gonna just tack down a few more pins on this side, and finally the right side. So the reason we're going quickly and we're not doing a perfect job is because I still need to actually solder down the centerpiece, the grounding pad, with the hot air. And if I get everything perfect, it might get undone while I do the hot air. So I just want to get a few of the pins down first. Alright, so we're going to be doing the same amount of heat. And I'm going to be pressing down a little bit with my tool. And I think we've actually already reached temperature here. Alright, and now I can go ahead and perfect my soldering. And this is our final side, which I don't remember if I did a rake check yet, so let's go ahead and do that now. Okay, perfect. I did remember we soldered it, but I didn't remember if we had checked it. Before we check the capacitor, let's go ahead and do a little cleanup. There's a lot of flux everywhere. And we're getting about 34.8 kilo ohms. So now our short is gone, we're getting an appropriate reading. Now we can go ahead and live test it. I've already plugged everything back in, so we're just gonna apply power and wait a few seconds, checking our IR and our light here on the USB as well as the optical. Now by now I would have expected the flash drive to start illuminating, and same with the standby, but we're not getting anything. Power button is not responsive, so it looks like we must have missed something. Let's go ahead and just bring it back to the test bench. Unfortunately, we weren't able to finish this repair yesterday, but after a little bit more time, we were able to identify the fault here with the board. Similarly to a recent video, if we take a look at the Ethernet port, we'll notice the resistor bank on the bottom right is burnt. So this is what it looks like up close, and this is what it's supposed to look like on a good board. Now what this means is that this board, the TV that it came from, was hit by a lightning strike via the Ethernet port. This is not information we were made aware of, and I did it off screen, but after we did the silicon image replacement, I did check the processor and I did not find any shorts whatsoever. Because we did have a lightning strike enter through the Ethernet port, however, it does mean that our processor is most likely damaged, even though I didn't find any shorts, so our next step is going to be to replace that next. All right, Juan, I have yet another rework for you.
Again?
Yeah.
All right.
Full disclaimer, this video is officially over, regardless if this board works or not, because I'm pretty tired of working on this board. So hopefully it works, and it's not. Oh, yeah. We have, our flash drive is turning on. I actually thought it wasn't gonna work. And will our standby light and optical turn on? Oh my God, the optical's on. Yes. Yes, it works. Oh my God. Thank God. Whew. All right, so the Ethernet's not working still, even after replacing that resistor, and I fear that there's some inductors and additional resistor banks that need to be replaced, but we're already getting to the end of the day, so we'll just go ahead and check for now our HDMI ports, since we haven't been able to do that since the HDMI processor replacement. And we have our Fire Stick working. If you found the video helpful or useful, make sure to leave us a like and subscribe, and thank you for watching.